Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. In following with respect to x, we have 1 by square root of 2 plus x the whole square minus 1. So what we've been given is dy by dx and we've been asked to find y. My y is nothing but integral of the given expression. So let's write down what our y is. So that's my y, and I know that my y is not in a very simple format whose antiderivative I know from first principles. But then when I take a closer look at this, I see that I have a square root in the denominator, and within the square root, I have a 2 plus x the whole square minus 1. And what does that indicate to me? I always suggest that you must try and connect it with one of the techniques that you have learned so far in integral calculus, right? And when I take a look at this problem, immediately you should be able to draw a parallel to integral of dx by square root of x square minus a square, right? So how do I bring it to that format, right? So step one would be to make an appropriate substitution, and that substitution is not very difficult. T equals 2 plus x, so that I bring everything in the form of t. Dt becomes equal to dx, right? And then I have a 1 out here inside my square root. My 1 is nothing but root 1 the whole square, which is again a 1 square, right? So 1 square equal to 1. Therefore, I know that in the subsequent step, I should be able to bring it to the format dx by square root of x square minus a square, just that in place of x, we have a t now. So my numerator becomes dt, and then my denominator becomes a square root of, in place of 2 plus x, I have a t right now. So let me call that t square. And then the second part is a 1 square. So now we have y equals integral of dt by square root of t square minus 1 square, right? Now it's not too difficult for us to solve that. We will solve this using the method of trigonometric substitution. So all that we will have to figure out is what is that substitution I need to use. Whenever you get a problem of this type, right, integral of dx by square root of x square minus a square, I want you to connect it with secant square theta minus tan square theta equal to 1, right? So the substitution that we will make out here is t equals 1 times secant theta. And why am I stressing on this particular one? Because we have a 1 square, and let's imagine we had a 2 square out there. The substitution that you would have to make is 2 secant theta, right? So right now in place of a, you have a 1. So the substitution that you normally do is t equals a secant theta, and in place of a, you have a 1 out here. And that's why we're making the substitution t equals secant theta. I hope you folks are with me, and in case you've not understood any of the steps, do make a mention of that in the comments, and I'll be happy to support you. Right now, with this substitution, I know what is my dt. My dt is nothing but a secant theta tan theta d theta, right? And this is something that I expect you to know from first principles lessons we learned in differential calculus. Now I go back to my y, and I try and rewrite everything in terms of theta. Let's see what do we get. Now I have integral of my dt, which is in the numerator, which is what we evaluated just now, becomes a secant theta tan theta d theta. And then my denominator, I have a square root of secant square theta minus 1, which is nothing but tan square theta, and then you have a square root of tan square theta, which is nothing but a tan theta, right? So now you understand why did I make the substitution t equals 1 secant theta, right? And imagine if you had made a substitution a sine theta or a cos theta, you would have struggled to solve this particular problem, right? And when you practice more and more problems of this type, I'm sure you will be able to arrive at what is the substitution that I need to make to solve this problem easily, right? Now I can cancel out the tan theta in the numerator with the tan theta in the denominator, and I'm left with integral of secant theta d theta. Now this is something that I expect you to remember. I'm not going to get into the details here. So we get log of secant theta plus tan theta, and of course I remember to insert the mod sign here. And so I have my final answer. I have solved for y, but take a look at this. This is in terms of theta, whereas we started off in terms of x. So all that I need to do is put back everything in terms of x, right? So we did two substitutions out here. The first substitution that we made was t equals 2 plus x, and the second substitution that we made was t equals secant theta, right? So let's start off with the most recent substitution that we made, which is t equals secant theta. So my secant theta becomes equal to t. And my tan theta is nothing but a square root of secant square theta minus 1, which means it becomes a square root of t square minus 1, right? And then we are not done yet because we did two substitutions like I mentioned to you earlier. And so second substitution that we would make to solve this particular problem is put back t in terms of x, right? And that's not too difficult because all that we need to do is replace t with an x plus 2. There we are. My answer to this problem is log of x plus 2 plus square root of x plus 2 the whole square minus 1, and remember the mod sign inside the log, and then I have my arbitrary constant plus c, right? So let me highlight my final answer in pink. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.